Okay, welcome back Physics 30s to our next lesson, which is 6.2, and today we're going to be talking about Rutherford's Planetary Model. Okay, so in the last lesson, we talked about Thompson's experiment and how he discovered electrons, and that he determined that electrons were very, very small negative charges that were placed in the atom like raisins in a bun. But now we're going to talk about how our understanding of the atom continued to progress. So our next scientist to study and further the atom is Rutherford. Rutherford wanted to know more about the atom, so he thought, what if I shoot it with stuff? So he gets this alpha particle gun, and an alpha particle is like a really small, heavy thing. It's like the nucleus of a helium atom. And then he wants to shoot it at atoms, so he takes a piece of gold and just pounds it super thin and tries to get it to being 1 atom thick. Now, with what we know about the atom, he probably got to like 100 atoms thick now. You can't get it that thin, but he was pretty close. So over here is his alpha particle gun, and he's going to shoot it at this really thin gold foil. Now what he's expecting in his experiment is for the alpha particle to be shot and pretty much just go right through the gold. This is because from Thompson's experiment, we thought that the atom is pretty kind of spread out with its mass, like a raisin bun. So this is kind of taking a gun versus a raisin bun. The bullet represents the alpha particle, and the thin gold foil represents kind of like a sheet of raisin buns. The total mass of the gold here would be more than the alpha particle, kind of like all these raisin buns would be more than the mass of a bullet. But because the alpha particle is so dense, we expect that it's going to go through these atoms or through these raisin buns. And for the most part, that's what happened. The alpha particle was shot, maybe deflected a little bit, but came out on the other side. However, once in a while, the alpha particle bounced off. And he was like, what? You shoot a gun at a raisin bun and it bounces off, you'd be pretty shocked. So to explain this result, he says that the atom must not look like this. For the alpha particle to bounce off of this, it must be hitting something pretty dense. So he thought, what if all the mass isn't spread out like this, but it's more centralized into a very small, very dense nucleus, as we can see in this diagram. The overall size is the same because the raisins here are just orbiting around the outside. But in between here is absolutely nothing. Wait, absolutely nothing? Yeah, electrons around the outside, whole bunch of nothing, then a very tiny nucleus. So atoms are mostly hollow? Yeah, very much so. Okay, so you're saying that atoms, the building blocks of all matter that make up pretty much everything, are mostly made of empty space? Yeah. Holy this idea is kind of hard to comprehend. This means everything isn't kind of hollow, it's mostly hollow. And to put this to scale, imagine the size of a football field, and that is going to be the radius where the electrons are going to be orbiting. If we're going to imagine how big the nucleus is going to be and how much empty space there is, in the size of a football field, the nucleus would be about the size of a marble. So imagine putting a marble all the way to the center of the middle of this football field. Think about how much empty space is around the outside. That's what the atom looks like. Apparently when Rutherford discovered this, he was afraid to walk on the floor because he realized it was mostly nothing and he thought he would fall through. Now, I don't know if that's a true story, but it helps to make this a little more memorable. Now, it's crazy to think that this just isn't for gold foil or the floor, but it's also for you because you're made of atoms. Kind of like being made out of balloons where all the mass is just in the center of the balloon. Now, what if you could pop all those balloons and get rid of all that empty space? You would be super tiny, and yet you would still have the same mass. This would never happen to you. However, things this dense do exist, and they're called neutron stars. A neutron star has about 1.5 times our sun's mass. However, it is only about 20 kilometers in diameter. It's super dense, and it's because it has none of that empty space. It's all those nucleus really close together. If you took just a teaspoon of this neutron star, that would weigh 1 billion tons. Crazy. But anyway, to conclude, that's our next advancement of the atomic model. It's Rutherford's planetary model with a very dense nucleus in the middle, and then the electrons orbiting around the outside. That's it for today's lesson. Thank you so much for watching this video, and I'll see you in the next lesson where we talk about the Bohr model.